One of the first things I want to talk about is randomization. And this is a concept that we're super familiar with. Randomization is really, really important when we want to create computer programs that have a degree of unpredictability. Now, the biggest category of that is, of course, games, right? Can you imagine if you had to play Tetris and every single time the block that fell down was like predictable? You always knew that it was going to be a T and then it was going to be an L. Like, there would be no fun in that, right? So how do we create this randomness for our programs? Now, in nature and in our everyday lives, it's really easy to create randomness. If you splash some paint on a canvas, that's going to be pretty random. If you take a look at the TV static from the analog TVs, that's also a whole bunch of randomness there. But when we're talking about computers, then these machines are what we would call deterministic. They will perform repeatable actions in a fully predictable way. So how do we wrangle these machines that operate basically on ones and zeros to get them to create some random numbers? Well, there's a whole bunch of maths that can be applied to create what are called pseudo-random number generators. And the one that Python uses is something called the Mersenne twister. And if you really want to read about it, then you can have a look on Wikipedia and take a look under the algorithmic detail. But to be honest, it's a little bit too much information for anybody, unless you're really interested in these types of number generators. But what I recommend though is a free video from the Khan Academy where they explain pseudo-random number generators. And it's really well produced and it tells you a lot of different aspects of pseudo-random number generation. So have a look at that if you're interested to learn a little bit more about pseudo-random number generators. We've talked a lot about randomness, but let's see it in action. Let's write some code and produce some random numbers. Head over to the day4 starting REPL and then go ahead and fork your own copy. We know that we want to get hold of some random numbers, but we don't really want to implement the Mersenne twister ourselves because it's horrendously complicated using lots and lots of maths and probably will take us months to write the code for. So how can we get random numbers? If you think about it, it's a little bit like searching for something in Google. The Google algorithm is horrendously complicated and it's taken them years and years to refine and perfect to such an extent where I think Google knows me better than myself, because when I search for something, it always gives me the most relevant results. And if you're questioning the complexity of the Google algorithm, just go to Bing and try searching for something and see how relevant the results are. So they have this super complex algorithm, which we're never going to get a chance to see, let alone understand. And yet, every day we're able to search things on Google and use this Google algorithm to get the things that we want, like the airspeed velocity of a laden swallow. Now we can do the same thing when we want to generate random numbers. Because this is such frequently needed functionality, the Python team have already created a random module. So if you head over to askpython.com and search for the Python random module, then you'll be able to see the documentation for this random module. And you can see that it contains a whole bunch of functions that you can use that allows you to generate random integers, so random whole numbers or random floating point numbers. So let's see how we can tap into this random module. In order to tap into the random module, we first have to import it. So we write import random. And now we're able to use this random module in our main.python code. We can start using the documentation to generate a random integer. For example, they show us in the code snippet here that we could generate a random integer by using the randint function, providing an a and b, and it'll return a random integer between a and b, including both of those numbers. And there's even a little bit of code snippet to show us how it's done. So this line of code generates a random whole number between 100 and 200 and including those two numbers. So it could be anything between those two numbers. So let's see if we can implement this in our code. Let's say that we want to create a random integer And we use the same code that we saw in the code snippet. We say random, that's tapping into this module here, dot rand int, and then we add a set of parentheses, and then we specify the start, comma, and then the end. So this is basically a range of numbers that we're specifying, any integer between 1 and 10. And now we can go ahead and print our random integer, just like that. And every single time I run it, you'll notice that I'll get a different number, or maybe sometimes the same, but it's a random number between the range that I've specified. Now, I've mentioned that the random module is a Python module. So what exactly is a module? Well, you've seen that we've mostly been writing our code all on the same page in a sort of script style, right? And everything just kind of gets executed from top to bottom. But sometimes your code will get so long because you're trying to create something complicated, and it's no longer possible to understand what's going on in such a large piece of code. What people will do in that case is to split the code up into individual modules, where each module is responsible for a different bit of functionality of your program. And if you have a complex project with many, many modules, then you could have collaboration on your project, right? Lots of people could be working on it, each person working on a different thing. Say if a factory was building a car, it wouldn't make sense for one person to build the entire car, from wheels to axles to the chassis. That's crazy. Instead, you have different people working on different modules, like the tire module, or the chassis module, or the engine module. And then once they put everything together, you end up with the final car, or in our case, the final program. So we know that the random module is a module that the Python team created to make it easier for us to generate our random numbers without needing to get into the complexities of all of the math that's required to generate pseudo-random numbers. But how can we create our own modules, and how do modules work anyways? Well, it's actually very simple. If you go ahead and click on the files icon, you can see we currently only have one file that we're writing in, which is main.py, the Python file. And the main.py is the entry point to our program. This is the file that will be executed when we run our code. Now, if I go ahead and click on this icon to add a new file, let's say I call it mymodule.py, and I create a new Python file. And inside my module, I'm going to maybe work on something else. Let's say I wanted to store the value of pi. Okay, I think that's all I remember. So I know the value of pi, and I want to be able to use it in my different programs. Now that I've created my module.py, well, now I can use my module wherever I want just by importing it. So I could import my module. And now down here, I can say, let's go ahead and print my module.py. And now if I go ahead and comment out this code and hit run, then you'll see we get that value of pi that got dragged in because I imported my module. But now we've got our code separated out into separate modules that are responsible for different things. And that is how the random module works as well. So I'm going to go ahead and delete all of this stuff relating to pi, but you can keep yours if you want to keep it for reference. Coming back to creating random numbers, we've seen how we can create random whole numbers, but what if I wanted to create a random floating point number? Well, it tells me how to do it in the Python documentation, and all I have to do is use the random module that contains the random function, and it will return a random floating point number between 0 and 1. But it's really important to note that in this case, it doesn't actually include 1. So it goes up to like 0.9999999, but not including 1. Let's go ahead and try that out. So we'll say random float equals random.random and then a set of parentheses. And this will give me output some sort of number in the interval between 0 and 1, but not including 1. So let's go ahead and see if it works. first we print a random integer between 1 and 10, and then we print our random float between 0 and 1. And every time we run the code, you'll notice that we get different random numbers. Now, here's a question. This random function always generates a number between 0 and 1, and it has many decimal places. But what if I wanted a random floating point number between 0 and 5? How might we do that? Now, it's not as complicated as you think it is, and you'll be able to do it just by looking at the code you've got here. Have a think about it and see if you can come up with the answer. I'll go through it with you afterwards. Pause the video now and give that a go. Alright, so we know that this random float can be anything between 0.00000 to 0.99999, effectively repeating, right? Now, what if we were able to multiply this random number by a number? Let's say that I multiply the random float by 5. Well, what if this random float was 0.1? Well, 0.1 times 5 would be 0.5. But what if the random float was 0.4? 0.4 times 5 would be 2. Or what if it was 0.9? 0.9 times 5 is 4.5. So effectively, by multiplying this random float by 5, I will end up with random numbers, but of course they're now floats, right? So it could be 0.000 ... all the way to 4.99999 and etc. etc. So this is how we can expand that range from 0 to 1 all the way to 0 to 5, but not including 5. So what can you do with random numbers? Well, if we think back to our love calculator that we made in the last lesson, it's kind of based on pseudoscience, right? Like, just because you have a certain number of letters that exists in the word true and love, it doesn't mean that you're actually going to be more compatible. I'm sorry to break anyone's heart out there, but if it's random anyways, then why don't we just use a random number generator, saving ourselves all of that trouble from counting T's and counting U's. We can instead just simply say love score equals random int between 1 and 100, and then go ahead and just print your love score is, and then let's insert our love score and turn this into an F string. Let's print that. And you can see that we're getting a different love score every single time I run this code. It's between 1 and 100. And, who can tell that this is any different from the previous method, right? So we can use our random number generator for this. We can use it for creating a dice or flipping a coin, or we can use it in games that we create. If you head over to the next lesson, I've got a code challenge for you where you're going to be building a program in order to pick from heads or tails and help the user out when they don't have access to a coin. For all of that and more, I'll see you on the next lesson. In this exercise, you're going to create a virtual coin toss program, and it's randomly going to tell the user whether if they got heads or tails. It's important that the first letter should be capitalized and spelled exactly as in the example, because we're going to test for it. And there's many ways that you could do this, but to practice creating random numbers, you're going to generate a random number, either a 0 or 1, and then use that number to print out heads or tails, where 1 is heads and 0 is tails. So the example output should just be heads or tails, and that's all there is to it. So have a go at this. So the first step to use the random module is to actually import the random module, and we do that on line 1, import random. And then we use a function inside the random module called randint, which generates a random integer, a random whole number, and we get to define what that whole number can be. And we do that by writing 0, 1, so either 0 or 1, And then we assign the value that gets generated from this random coin toss into a variable which I've called random side. Now finally, because we know that the random side can only be either 0 or 1, we do a conditional check where we check to see if it is 1, then we're going to print out heads, and if it's 0, we're going to print out tails. Hey guys, today I want to talk about something that is really, really important and you're going to use many, many times in the future. And this is the concept of the Python list. And the list is what you would call a data structure. What does that mean? Well, it's just a way of organizing and storing data in Python. Now, we've already seen ways of storing single pieces of data, and that was done through the simple variable, where we just said A is equal to 3 or B is equal to hello, but that's just storing one piece of data, right? Be it a number or a string. But sometimes you might want to store grouped pieces of data that has some sort of connection with each other. For example, if you wanted to store all of the names of the states in the US, then it doesn't really make sense to store them all individually because they kind of belong together, right? They have a relationship to each other. So it would be nice if you had a variable that was called states in the US, and then you would be able to store all of the names of the states together in one variable. Now, in other cases, you might also want to have order in your data. So for example, if you were storing all of the people in a virtual queue, then you want to be able to keep hold of the order in which they joined the queue. You don't want to let the last person somehow skip the queue because you don't have a good data structure, right? This is why we need to learn about lists. And lists look pretty simple. It's just a set of square brackets with many items stored inside. And those items can be any data type. They can even have mixed data types, like you could store strings together with numbers or a set of booleans. It doesn't really matter. But what does matter is the syntax. In Python, lists always start with an open square bracket like this and a closing square bracket like this. And then in between, you have your items separated by a comma. So pretty simple. In order to store it inside a variable, then it's the same way as we've done before. The only difference is the right-hand side of the equal sign. This is the list data structure. If we stored a bunch of fruits, for example, then it might look something like this. Cherry, apple, pear, separated by a comma inside a set of square brackets. Let's take a look at this using real code. Now, I'm going to go ahead and comment out the code from our previous lesson on randomness, and you can do the same if you want to keep a note of the previous code and use it as sort of a live textbook where you can comment out the code or comment it back in order to see how it works, or you can delete it. It's totally up to you. Now, let's say that I wanted to store all of the names of the states of the US. Previously, without knowing about this list data structure, we might have written state 1 equals Delaware, state 2 equals Pennsylvania, and so on and so forth. And we would create as many variables as we have states. But now that we know about lists, then we can just create a single variable and we call it states of America. And now we can create a list by creating a set of square brackets. And inside those square brackets, we add our items. So again, the first item is the state of Delaware, which is going to be a string. And then we've got Pennsylvania, etc., etc. And we can continue this list just by adding commas, adding a piece of data, adding another comma, adding a piece of data. And this way, we end up with a list data structure. Now, one of the interesting things about the United States is that the different states in the US actually joined the Union at different times. You can actually head over to Wikipedia and watch this little animation and see each state join the Union and at which time point they did so. The order of this data is now kind of pretty important. Because if we wanted a list of US states that are in the order that they joined the Union, then the order in which they're stored in our data structure is now also immensely important. And this is another thing that you get with lists. You can use lists to store many pieces of related data, but they also have an order, and the order is determined by the order in the list. So this is the first piece of data, this is the second piece of data, and when you store it inside the variable, that order is not lost, and you'll be able to use it later on when you need the list. Here's a list of states of America ordered by the date that they joined the Union. And you can see that if later on I decided that I wanted to know which was the state that joined first, then I can print this variable, States of America. I can add a set of square brackets, and then I type 0 as the index of the piece of data I want to pull out from my States of America list. So now if I go ahead and run this code, you can see it prints out Delaware. And if I keep increasing this number, you can see that it's going through my list in the order that it was saved. So you might be wondering, that's kind of weird that you typed 0 and you got Delaware, right? Surely Delaware should be the first item in the list. Well, this is a kind of peculiarity with computers and programming languages. You'll tend to find that programmers start counting from 0. So Delaware is at 0, Pennsylvania is at 1, New Jersey is at 2. And this idea might seem a little bit weird at first. Why is the first item at position 0? But if you think about that index number, that 0, 1, or 2, instead of being the position, actually being an offset or a shift from the start of the list. Well, then in this case, cherry is right at the beginning of the list, so it has a offset or a shift of 0, but apple is shifted from the beginning by 1, pear is shifted from the beginning by 2, and so on and so forth. Then it kind of makes more sense that the first item in the list is at the beginning of the list, so it has no offset, so it's 0. And you'll find that in many programming languages, there are similar data structures to lists, and this is how they're usually ordered, starting from 0 and then adding by 1. Now, you can see that when you want to get hold of a particular piece of data stored inside a list, what you do is you get the name of the list, and then you add another set of square brackets. So whenever you see square brackets, you should be thinking to yourself, oh, this might be related to a list. Because when you create the list, you use square brackets. And when you try to get items out of the list, you also use square brackets. And then inside the square brackets is where you put the index or the offset of the item that you want. So if we want a New Jersey, it's offset from the beginning by 1, 2. So now this part of the code is equal to New Jersey. And we could, if we wanted to, save it into another variable, or we could simply print it as we did before. Now, in addition to using the positive index, so say 0, 1, 2, 3, you can also use a negative index. So if I wrote -1 or -2, then it actually starts counting from the end of the list. So if I wrote States of America, square brackets, -1 as the index, then I get Hawaii. -1 is the last item in the list, because you can't really have -0. That's not actually a real thing in maths. Now, as I continue and I go to -2, then that's Alaska, -3 will be Arizona, and so on and so forth. So you can have positive indices and negative indices. But so far, we've only been pulling things out of our list by using our square brackets and the index. But you can also change the items in the list using very similar code. For example, if I decided that Pennsylvania is actually not spelled Pennsylvania, and I wanted to change it to Pennsylvania, then I can simply write my code like this. I get hold of my list, and then using the square brackets, I get hold of the item at index 1, which is this one, and then I set it equal to a new piece of data. So now if I go ahead and print my States of America list, you'll see that the list looks a little bit different now. Instead of Pennsylvania, it's now Pennsylvania. So you can alter any item inside the list pretty easily using this kind of syntax. You could also add to the list if you wanted to. So for example, if you wanted to add an item at the end of the list, which is what happens most commonly, right? If you had a list of people who are queuing in your shop, then every subsequent person usually gets added to the end. If you have a new state that joined America, then it's probably going to be added after Hawaii. How do we do that? Well, we can write the name of the list, and then we use a function called append. And append will add a single item to the end of the list. So let's say that Angela Land is joining the United States of America. So now, once I've appended Angela Land to the end of my States of America list, and I print the States of America, you can see there it is added right at the end. Now, there's actually a whole load of other functions that you can use in addition to append, and you'll find this on the documentation for Python. In addition to the append function that we saw just now, where we add an item to the end of the list, there's a whole load of other functions that you can use with lists. For example, you can use the extend, which adds a whole bunch of items to the end of the list. And in this case, what you're actually adding is going to be a list. So I would be creating the list using square brackets and then adding my items in here. And now what's happening is I'm extending this States of America list with this additional list. So now if we print the States of America, you can see that these two items that used to be inside the list have now been added to the previous list, and it's now extended it by two more items. But the important thing is you don't have to memorize these functions. That's the whole point of documentation and why we have Google, because there's too much information in the world for you to memorize, and it's a very inefficient way of learning. And if you tried to memorize every single method, it's not impossible, but it means that you don't have space in your brain for the important stuff, which is how things work. How do you actually use it to do what you want it to do? So what I recommend when you come across a new thing, such as the list data structure, is to just have a look through the documentation, read through it, and see what are the possible things you can do. And once you've got the idea of this is possible, then the next time when you need to use it inside your code, you'll know, I remember this is possible. And all you have to do is just be able to use Google to find the exact bit of the documentation and then implement it. Programming is kind of like an open book exam. You shouldn't need to memorize anything. You should spend your time trying things out and try to get things to work instead. Now that I've introduced you to this new data structure, the mighty list, it's time for a code exercise to see if you can use it in practice. So head over to the next lesson and give the challenge a go. In this exercise, you're going to write a program that is going to select a random name from a list of names. And the person selected will have to pay for everyone's food bill. This might be handy when you're going out for dinner with your friends, or maybe when you're going out with your colleagues and you want to keep things simple. So this is a banker roulette. And the idea is we're going to put a bunch of names into the input area, and these names will be separated by a comma and a space. This is very important. On line 1, we've got some code that is going to do some pre-processing. It's going to take the input and it's going to split that string by a comma and a space. And then it's going to add each of those names into a list, which you can then access in that names variable. Now, don't worry about getting hold of the input. We've already sorted that out behind the scenes for you. All you have to do is, given a list of names, how can you pick out a random one from those names and then print out that name, and then the phrase is going to buy the meal today.
So take a look inside the example input and example output and figure out how you can get this to work. Once you're done, hit submit and then test your code against our pre-formatted test cases. Now remember, your output can only have one line and it must match the format written in the example output. All right, let's work through the solution together. The first thing we're going to do is to get hold of the total number of items in the list. So we're creating a variable called numItems, and we're using the len function in Python to calculate how many items there are in our list, that is the list of names. Next, we're taking the number of items, we're subtracting it by 1, because remember, lists start from 0 and then to the last index. So if a list had 3 items, then it would be at positions 0, 1, and 2. So that's where we're subtracting number of items by 1. And then we're using random.randint in order to get a random number between 0 and the last index. And then that is going to be the number we're going to use to pick out a random name in the next step. Once we've got our random number, then it's as simple as taking our list of names, putting a square bracket afterwards, and then putting our random choice, that random number, into the square brackets to pick out a random name. And finally, we put that name into our print statement and print out that person is going to buy the meal today.
Now, when you're working with lists, one of the most common errors you'll come across is something called the index out of range error. In fact, by this point, you might have already seen it. Now, what does it mean though? Well, let's take our states of America and let's delete the line where we added Angela Land and Jack Bauer Land. So we go back to the original. And you might remember that there are 50 states in America, but if you don't, because you're a programmer, it's as easy as writing len and then passing over the states of America, which will print 50. So now that we know that there are a total of 50 items in this list, and remember, because we start counting from 0, Hawaii is actually at index 49. So if we print States of America and then we try to get the item at 49, we hit print, you'll see that we get Hawaii printed. Now, what if we went one beyond that? What if we tried to get the one at index 50, somewhere out here? What do we get instead? Well, we get an error. It's called an index error. And this is because it's beyond Hawaii and there's nothing there, as we can see with our own eyes. But when you're working with large lists and you're not always looking at the data, then these errors can be a little bit more confusing. Very frequently, when you're working with lists, you'll end up with an off by 1 error. So it's unusual that you'll try to get something at index number 90 because that's just way beyond your list size. But very frequently, you might end up in a situation where you have some sort of value, say number of states, equals len, and then we pass over the states of America. So this is going to be equal to 50, and then we pass that inside here as the index num of states, and then we hit run, and we get the same error, right, on line 16, where we try to get hold of this index in this list. It's again, list index out of range. And this is an off by 1 error because all we need to do is just simply minus 1 so that 1 becomes 0 and 50 becomes 49. And then we get rid of that error. Now, it might be easier if we work with something a little bit simpler. Recently, I was reading online and I came across the so-called dirty dozen, where the environmental working group, a bunch of people, crunched through a whole lot of data, probably using Python, and they released their dirty dozen, a list of the fruits and vegetables that have the most pesticides. And it's kind of crazy that they actually washed and peeled all of these foods and then tested them for pesticides. And the list looks something like this, where strawberries are apparently one of the worst offenders for pesticides. So let's create a list of the dirty dozen. But you'll notice that some of these are fruits like strawberries, apples, and other ones are vegetables. So how can we use our lists to still keep them inside the same sort of container, the dirty dozen, but somehow separate them out into fruits and vegetables? Well, we could just simply create two lists, fruits and vegetables. But these two lists kind of have a relationship, right? They're kind of related because they're all on the list of high pesticide foods. So how can we have lists within a list? Well, that's what's called a nested list. Instead of our original dirty dozen, we could create a new list called dirty dozen, and we set it equal to a list that contains two lists. It contains fruits and it contains vegetables. So now what effectively has happened is we've inserted this list inside here, and then we've inserted this list inside here. So we now have a list that contains two lists. And if I go ahead and print out this list, you'll be able to see its structure. And it looks like this. You'll notice that there's two brackets at the beginning and at the end. And the reason is because this is one list, this is another list, and this is also a list. So this is yet another way of using lists and just showing you the flexibility of this particular data structure. It's something that you're going to use a lot when you're writing Python code. Now that we've talked more about index errors, how to fix them, and also nested lists, you're ready to go to the next coding challenge. So head over there and give that a go.
All right, it's time for yet another difficult coding exercise. So this is a difficult challenge. What you're going to do is you're going to pretend to be a pirate. What do I mean by that? We're going to use what we've learned about lists, and especially nested lists, in order to create a treasure map. So we've created a treasure map by creating three lists, which I've called line 1, line 2, and line 3, and I've combined them into a nested list by using the code on line 4, where I said map equals another list that contains three lists. Your job is to take an input in a similar format to how you see maps are formatted, where we can take a letter and a number and then use those letters and numbers to access a particular location in our list and convert the entry into an X to mark a spot on our map where we've buried our treasure. Have a read through the instructions carefully, figure out how this is supposed to work, and then write your code in main.py between the two sections that I've already written for you. So we've got a print statement that prints out all three lines, and you shouldn't change any of the existing code in order to complete this challenge. It's a difficult one. Have a think about it. Think about the example inputs and example outputs in the instructions and give this a go. All right, I did warn you, it's a difficult one, but there's no shame in checking the solution, especially if you've given it a good go. The first thing that our code does is to grab hold of the first letter that's in the input. In this case, it is B in the example input. And what we're going to do is we're going to use position, which takes the entire input, get the letter at the first index, so position square brackets 0. And now we have that first letter from the input. Now, the next thing we're going to do is we're going to turn this letter into lowercase so that we can compare it against a comparable. I've used the dot lower on line 8 in order to lowercase the input letter, just in case a user used a capital. And then on line 9, I've created a list that represents the three possible letters. We've got A, B, and C. Now, you could do it the other way and make it go uppercase as well, but everything has to be uniform in order to make sure that the user input, doesn't matter if they put in lowercase or uppercase, our code will still work and can compare it against the values in this list of ABC. In order to do the comparison, we're using a method that comes from the Python list called index. So the way that we do this is we take the name of the list, which is ABC, and then we write .index, and then in the parentheses of that method, we pass in whatever it is we want to check that exists in the list. If the letter was B, as in this case in our input, then abc.index B is going to give us a number. It's going to give us 1, because remember, lists start from 0, so A is at index 0, B is at 1, C is at 2. So now letter index is 1, and we can work with it in order to get hold of the item in our map that we want to change. This part is a little bit difficult to conceptualize, but you can try thinking about this code, printing out what the values are, and making sure you understand. The next part is getting hold of the number index, which is a lot easier because we can simply take the input, which comes in through the variable position, get the value at index 1, which is the second digit or letter in the input, and in this case it's the number 3. And in our map, because we have a list, and remember lists start from 0, so actually position 3 is equivalent index 2. So we always have to subtract 1 in order to get the index because it starts counting from 0. So now we have the number index. Finally, we can bring up our nested list, our map, and put in both of these indices in order to change the item at that position to the letter X. The thing that might be a little bit confusing here is the first part is actually the number index, because remember we said that with nested lists we go from outside to in, and what that means is we've got a list of lists. So if you look at line 4, our outer list is our map with line 1, line 2, line 3. And the part of our input that determines which of those lines we're going to pick out is actually the number, not the letter. So that's why the first index that goes in is the number index. And then once we've gotten onto the correct line 1, line 2, or line 3, then we use the letter index in order to pick out the right element in that nested inner list. This, again, is a little bit mind-blowing. It's difficult to get your head around, but it's okay. If you just try it a few times, try the code, try some different combinations, and eventually you will get around to this programmer's way of thinking, which is a little bit different to what you might be used to. Be patient with yourself. If you have any changes you need to make, go back to the previous slide and make it now.
All right, guys, so now that we've loaded up all the knowledge that we need into our brains, it's time to tackle the final project of the day. And as I showed you in the beginning of the day, it's a rock, paper, scissors game that we can play with the computer. So the game starts out by asking you to type 0 for rock, 1 for paper, or 2 for scissors. So let's go ahead and type 2 for scissors. And then it's going to show you a graphic of your choice, scissors, and then the choice the computer made, which is rock. And of course, rock beats scissors, so you lose. What this game boils down to is some way of randomly making a choice between rock, paper, or scissors, and then comparing that choice that the computer randomly generated against your choice, and then based on the rules of rock, paper, and scissors, determining whether if you won, you lost, or whether if you had a draw. While I was looking around, I actually came across the World Rock, Paper, Scissors Association. And they have the official rules listed of rock, paper, and scissors. If you're not familiar with this game, it might be worth checking out this website. Here are the 3 shapes of rock, paper, and scissors. And then the rules are that rock wins against scissors, scissors wins against paper, and paper wins against rock. Having all of this in mind, head over to replit/@brewery/rock-paper-scissors start and go ahead and just fork the starting project. Now, you'll notice that in the starting project, I've already got the ASCII art for rock, paper, and scissors in here, and they're each saved to a variable. So what that means is that you can start out by just having a go at printing out, let's say, rock. And remember that these are variable names. They're not strings, so they don't need the double quotes around them. So let's run that, and you can see what we get printed is the particular ASCII art that I chose in my print statement. So this is already yours, but as you'll notice, there's no other logic that I've provided you. And you are going to rely on what you learned in the previous days, and most importantly, what you've learned in today's lessons to be able to complete this challenge. And it's worth comparing the outcome against the game of rock, paper, scissors that I'll link to. There's a couple of things to think about, namely, how are you going to decide who won or who lost? How are you going to get the computer to choose a random shape, rock, paper, or scissors? And how you actually get this game to work in the same way that is demoed in this final version. I'm going to go quiet now, and I'm going to let you pause the video, and I want you to spend at least 10 or 15 minutes working on this. And if you get stuck, just try some things out, or maybe watch some of the previous videos in the day and just try to give it your best go and do a lot of struggling. Hopefully you're going to succeed, and once you're done, head back over here and I'll go through the solution with you. So pause the video now. All right, so we know that we've got all of this ASCII art, but for the moment, I'm just going to start off by pinning down the basic logic of this game. And it's really helpful for you as well if you start thinking about breaking down the larger problem, which is making the rock, paper, scissors game, into smaller problems that you can solve, like generating a random number between 1 and 3. So we have some sort of proxy for rock, paper, and scissors. And then maybe thinking about putting down the logic. Well, if the computer chose scissors and I chose paper, then I'm going to lose. Or if the computer chose rock and I chose paper, then I'm going to win. And putting that down on a flowchart using draw.io or something like that can make this challenge a lot easier as well. But without further ado, the first thing I need to do is to produce a user choice. Now, this is going to be the one that the user chose when they typed in a value. And in order to get the value from them, I'm going to need to use a input. And inside the input, I'm going to put the following prompt, asking the user, what do you choose? Type 0 for rock, 1 for paper, or 2 for scissors. Now, once I get hold of this input, hopefully, if the user is following my instructions, they're going to type some sort of number, either 0 or 1 or 2. Now that I've gotten hold of what the user wants to choose, the next thing to do is figure out what the computer is going to choose. So I'm going to make another variable called computer choice, and I'm going to generate a random number. So to do that, remember we have to import the random module, and then we can start using it to generate random whole numbers by using random.randint, and then the range is going to be between 0 and 2. Because this is what I asked the user to do. Type 0 for rock, 1 for paper, 2 for scissors. So the computer is also going to choose between 0, 1, or 2. Now that I've got the computer choice, I'm actually going to just print it out for now. Instead of printing out the actual shape, I'm just going to print out the number. So computer chose, and then let's go ahead and add a F string. And of course, that requires the F in front of the string. So now if we just play the game as it is, remember that testing your app while you're developing it is really, really good practice. It picks up on the bugs that you make along the way, instead of waiting until the end when you've done everything and then it doesn't work and you have to untangle all of the lines of code. At this point, I've already realized that it's actually not so great getting the user to type on this line. What I would much rather is to start a new line for them to type their answer on. So if I run the code again, then it should look a bit like this. My prompt is now here. So I'm going to choose 0 for rock, and then it tells me that computer also chose 0. So in this case, this would be a draw. But if I play this game again, you can see that the computer is probably going to choose something different. So I chose rock again, the computer chose 1, which is paper. So now we can start thinking about how do we compare these two choices and how can we define the logic of rock, paper, scissors. So I know that paper beats rock, scissors beats paper, and rock will beat scissors. So if 0 is rock, 1 is paper, and 2 is scissors, then 2 beats 1 and 1 beats 0. So that's very simple for us to check in terms of using if statements, right? We could simply just check, well, if the computer choice is greater than the user choice, well, then this probably means that the computer wins. But this is not true in all cases, right? Because if the computer chose 2 for scissors and the user chose 0 for rock, then the user should win rather than the computer winning. So we actually have some exceptions to this rule. How can we catch the exceptions before we go down to this level of generalization? Well, we could, instead of using this as an if, we use this as an elif, and we create another if statement which says, well, if the user choice is equal to 0, so if the user chose rock and the computer choice was 2, well, then this means that in this case, the user actually wins. Now, if we're thinking from the perspective of the user when they're playing this game, then they don't really care if the computer won or the user won. They want to know, did they win or did they lose? So let's change this wording a little bit. We'll say, instead of user wins, we'll say you win. And if the computer wins, then we'll say you lose. So now if we run our program and test it out, so let's say I'm going to type 0 for rock and the computer chooses 2, but we actually get an error. It tells us that the greater than comparison is not supported between instances of int and string. What's going on here? Well, remember that we get our inputs as a number, but the input is always going to be a string. So we want this to be a number, then we're going to have to wrap it inside an int. So now we turn it into a whole number. Now, this might be a good point to address, well, what should happen if they typed something that wasn't 0, 1, or 2? What if they typed 34? Well, then naturally, they should probably lose, right? So we can add an else statement addressing this situation. So we could say, else, we just print, you typed an invalid number, you lose. Cool, so that sorts that out. Now let's run our code again and see if it works. What do you choose? Type 0 for rock. I'm going to choose rock again. Computer chose 0, and it tells me that you typed an invalid number. Well, actually, 0 is not an invalid number. So what's going on here? Well, it's because it didn't fit this criteria. So I had 0, computer had 0, and it didn't fit this criteria because 0 is not greater than 0. So it basically defaulted to the final else statement. But what's actually happening here is that that was a draw. Computer chose rock, I chose rock. That's a draw in the official rules of rock, paper, scissors. So how do I catch that? Well, I could create another elif statement which says, well, if the computer choice is equal to the user choice, well, then we're going to print it's a draw. Now let's test our app again and see if there are any other situations where our code is not behaving properly. I'm going to choose rock again. Computer chose rock as well, and I get it's a draw. So that's pretty good. Now, if I choose 0 and the computer chose 2, then this is going to be the statement that gets triggered and I win. So that's pretty good. Now, what if I chose 2 for scissors and the computer chose 0? Well, in this case, rock beats scissors, so it should actually say, I lose. But instead, it says you typed an invalid number. So it defaulted to the else statement again, because this particular situation is not caught by any of these statements. So what do we have to do instead? Well, we actually need another elif to say, well, if the computer choice was equal to 0 and the user choice was equal to 2, well, this means that rock beats scissors, so I lose, and the computer wins. Now, the final one that we need to catch is this case. If I type 1 for paper and computer chooses 0 for rock, it again defaults to the else statement. Whereas in fact, in this case, it should tell me that I won. So what's missing here? Well, it's the partner to this particular statement. If computer choice is greater than user choice, then I lose. But on the other hand, if the user choice was greater than the computer choice, then I actually should win. So now the final thing we might have to fix is this else statement now actually never gets called, because this is what happens. So let's say that I choose 456. It tells me that computer chose 2. I win. What's happening here? Well, it's actually this particular line that's being carried out. User choice is greater than computer choice. This is not what we want. We want it to default to you typed an invalid number, you lose. So we can't actually just use else in this situation. We actually need to provide a condition. We're going to use elif to check if the user choice is greater or equal to 3. Now, the computer will never choose anything other than 0, 1, and 2, so we don't have to check that one. But the user could choose something above 3 or below 0. So we can use an or statement to catch this. Or if the user choice is less than 0, well, in this case, you typed an invalid number, you lose. But that's not all that we have to do. If we hit run and we again type some extraordinarily large number, you'll see that it still says computer chose 1, you win. What's going on? We have this statement that should catch this situation, but it's right at the bottom. So it's not going to be checked until one of the previous ones are checked. Namely, it's one of these that's going to be the problem. So what we have to do is we have to move this statement above all the lines so that we first check if the user choice is greater than 3 or less than 0. And if that's not true, do we actually continue checking to see who won the game? Now, finally, we can run our code, type an invalid number, and get you typed an invalid number, you lose. So now that we've actually got our logic all sorted out, the next step is to include our images. And to do that, we have to somehow match it up with these numbers we have, right? 0, 1, and 2. Now, there's many ways that you could do this and you could solve this project, but the easiest way is probably putting the game images into a list where we have rock as the first one, paper as the second one, and scissors as the last one. So we're using the fact that lists have a order that is always going to be followed. So we can now get hold of the rock picture by getting game images 0. We can get scissors by doing game images 2, and so on and so forth. And we can match those up to our choices, the user choice and the computer choice. So when the user chooses a number, then we're going to print from the game images, and we're going to use our little square brackets to select the image we want from this list. And the one that we want is going to be based on the user's choice, right? 0 for rock, 1 for paper, 2 for scissors. So we're going to put user choice as the index to pick out an image from game images. Now, down here for the computer choice, instead of printing the number that the computer chose, I'm going to delete that and add a little colon. So that way it's going to show computer chose, and then I'm going to print the image of the choice that the computer made. So I'm going to add another print statement. I'm going to tap into the game images, and then inside some square brackets, I'm going to use the computer choice, which is going to be between 0, 1, and 2, as the index to pick out the corresponding image from my list game images. So now we're finally ready to run our code, and I'm going to choose 0 for rock, and the computer chose paper. So paper beats rock, I lose. Let's try this again. I'm going to choose scissors, and computer chose scissors, it's a draw. But we have also introduced a bug. So if we test this using a number that's outside of this range, 0, 1, or 2, so let's try 5, and we hit enter, what do we get? We get a index error. So what has happened here? Well, this is up to you to debug. Well, this is a really good opportunity for you to practice your debugging. So think about what has changed since the last time we tested this and how you can fix the code so that it works as expected. So telling us that you typed an invalid number, you lose whenever we type a number that's above or equal to 3 or less than 0. So I want you to pause the video and see if you can debug this challenge so that when you type in 5, you get this printed. Pause the video now. All right, so what's going on here? Because we tested this and it worked, but in between that time, we also added this line because we wanted to get hold of the game images based on the user's choice. Now, at this point, the user's choice is unchecked by the if statement. So it could still be equal to 4 or 5 or 10 or a million. So if in that case it tries to get hold of the 5th image from the game images list, well, it doesn't exist. There's only 0, 1, and 2. So to fix this, we need to move this if statement so that it gets checked before this line of code gets carried out. So let's go ahead and cut this line of code out and put it right above this print statement. So in this case, if the user types in a choice that's above or equal to 3 or less than 0, we're going to print this, but else, if they typed in any other number, then we want the rest of the code to continue. So let's select the rest of the code, hit tab, and tab it over so that it's included under the else statement. Now let's go ahead and change this from an elif just to an if, because we're no longer checking it as another else if statement. It is just a straight up if. So in this case, if they typed a 5, then it will go into this basket and it will finish there. But otherwise, it will go into this basket and it will continue checking later on. So did you manage to debug your code and figure out the issue? This is one of the most important skills as a programmer. You'll have plenty of opportunities coming up to practice your debugging. And if you ever want more practice, head over into the Q&A and see what other students have issues with and see if you can help them out by practicing your debugging skills. Now we have completed the project by using everything from lists to randomization to variables to if statements and a whole lot of logic. So how did you get on with this project? If you struggled, this is the time again to go back to it and maybe map things out using a flow diagram, or try to run the code using Thonny to see how it does it step by step. But the important thing is that you got to write your own code and you got to make it work. And this is the only way that you'll understand what's going on so that you can continue on. And as things get harder, you'll be able to learn more because you've already understood all of the previous knowledge. So I hope you had fun with me today, learning and building. And hopefully I will see you tomorrow, bright and early. So that's good night from me for today. Hey, well done for completing day 4. I can see that you're really putting in the repetitions, putting in the practice, and this is what's going to take you really far. Because we all know that programming is not something that you can just learn passively. You can't sit in front of a TV, watch somebody talk about programming, and all of a sudden become a programmer. You have to put in the hours and the effort. It's a little bit like going to the gym, really. You're never going to become muscular and strong if you just watch a bodybuilding show, right? Even, if you watch Arnold Schwarzenegger every day, 8 hours a day, you will never develop those muscles that he has unless you actually hit the gym. So our version of the gym is coding. We're going to hit the coding editor and we're going to type every day until we get it. So have a break, have a rest, and come back tomorrow refreshed, and we're going to put in some more reps and we're going to train you up to become a great programmer.